Swayam Prabha. Digital India. Educated India.
We have the topic Inertia being presented by Shiv Nadar School and Kothari International School. We will start with Team A of Shiv Nadar School, comprising of Arika Sahai of Grade 10 and Sanvi Gupta of Grade 10. Please welcome them on stage.
You know, Sanvi, after eating breakfast, I just did not feel like moving.
I felt this feeling too. I just want to sit there and not move at all.
You know, this is a lazy tendency. And in physics, the name given to this tendency is inertia. And we are going to learn about it today. Hello, fellow scientists. My name is Arika Sahai.
And my name is Sanvi Gupta.
And we are studying in grade 10 in Shiv Nadar School, Gurgaon. So, in this session, we will be known as Professor Gati, arthat motion.
And I'll be known as Professor Ruki, arthat rest.
So, Professor Ruki, do you have any idea what inertia is?
I mean, I've heard of it, but I don't know exactly what it means.
I'll tell you. Inertia is the laziest tendency, and it is the best excuse to do anything wrong, ever.
To do something wrong, an excuse, how can Newton's law of motion be an excuse to do something wrong? I don't get it.
You see, Newton's first law of motion states that an object at rest will continue to stay at rest unless an external unbalanced force is applied on it, and an object in motion will continue to stay in motion with the same speed and in the same direction unless an external unbalanced force is applied on it. So, suppose you did not do your homework for school. What's your excuse? You were playing, and that's inertia, right? You could not stop playing. Similarly, if you were late for school, you were sleeping, and inertia, you could not stop sleeping. See? It's the most legitimate excuse to do something wrong.
Oh, I think I get it. For this, I have an experiment. But for that, I will need my friend Sam. This is Sam. Everybody say hi. Sam here is late to school. I know we've all been there. So to get to school, we're going to push Sam on a skateboard. Now he needs to get to school fast, so we're going to push him extremely fast. What happened? I pushed the skateboard to the front, but Sam fell backwards.
Before Professor Ruki explains why this happened, we'll show another example. This time Sam fell forward. You know, Sam is always this clumsy. You know, once when he was little, what happened was...
Wait. Professor Gati, just because Sam is a little bit clumsy doesn't mean there's no inertia playing on it. This is actually because Sam, when we pushed him on the skateboard in the front, we weren't actually applying any force on Sam. It was on the skateboard. So Sam wanted to stay at rest, which is why when the skateboard moved in front, Sam fell to the back. But when the skateboard suddenly came to a stop, Sam fell forward because he was already in motion, and because of inertia, he wanted to stay in motion.
Basically, inertia is a tendency that tells Sam कि Sam तब तक नहीं चलना जब तक कोई धक्का मार के चलाए ना और तब तक नहीं रुकना जब कोई पकड़ के रोक ना ले.
I'm sure you've all felt this when you're sitting in a car. Suddenly when the car brakes, you'll be jerked forward, and when the car suddenly starts moving, you'll be pushed back.
Let's demonstrate one more experiment. Here we have a sadhuji on a mountain. Actually, it's just a bottle with some coins. Now, हम थोड़ी सी बदमाशी करेंगे. हम इस mountain में earthquake लाएंगे. Let's see, can sadhuji concentrate despite this disturbance?
अरे Professor Gati, sadhuji को earthquake क्यों ला रहे हो? Let him concentrate. Meditation is a really good practice.
We'll see how effective his meditation is. Let's test his concentration levels. You see? His concentration levels are great.
What? But why didn't he move? You moved the coins, but Sadhuji stayed at his place.
I think you all know why this happened. That's right, it happened because of inertia. All these objects are in rest and they want to continue to stay in rest. When we apply this external unbalanced force, we apply it just on the bottommost disk, and therefore only the bottommost disk is brought into motion. The rest of the objects want to stay in motion, which is why this scale does not affect them.
Okay, we've tested Sadhuji's skills, but Professor Gati, how about we test your skills?
Sure.
Here I have a challenge for you. I have 2 jars with beads in each of them. 1 jar for me, 1 jar for you.
Okay.
The challenge is that you have to take the beads out of the jar. Wait, Professor Gati, इतनी गति से क्यों चल रहे हो? पूरा challenge तो सुन लो. You have to take the beads out of the jar using inertia.
That is not possible, Professor Ruki.
You wait and watch. I'm going to show you my skills.
Okay, you show me your skills.
Look at that.
Oh my God, how did that work?
Even though I pulled the beads out with an upward force, they still came down. This happened because the string was put into inertia and it was put into motion, which means once the string started moving, it kept on moving. And the beads on it, because they stayed in the same direction due to inertia, they kept going up.
But then why did they come down? They should continue going up.
Well, Professor Gati, this has a very simple answer, because of gravity. See, once the beads went up, because once gravity overcame the inertia force, they started falling down, creating an arch.
That's interesting. But now I have a challenge for you.
Another challenge? Don't you think this is getting a little bit competitive?
Are you a scaredy cat? Don't you want to compete with me?
Fine, let's compete. But I think that you're not going to play a fair game.
Let's test. All right, Professor Ruki. So here, I have an inertia walker for you. We are going to both use inertia walkers, and we're going to see whose inertia walker walks the fastest. You go first.
Okay, I think that's a fair challenge.
Rookie.
What happened? Why didn't it work?
That's sad. Now I'll show you mine. That's how it works.
Whoa, what happened?
You see, this is a paper box and it is powered by a very heavy steel spherical bearing. Now, this bearing wants to remain in motion, which is why it moves from one end of the box to the other, causing the box to do some awesome-tastic flips.
Whoa, that makes a lot of sense. But wait, if your inertia walker worked, why didn't mine?
You see, some secrets have to be revealed. I did not put a bearing in your inertia walker.
What? How could you not put a bearing in my inertia walker? I told you don't play fair games. See, this is so unfair.
I thought everything is fair in love, war, and inertia. I'll tell you one more thing. This is another example of inertia. Our Professor Ruki is extremely angry, and she's going to stay that way unless an external unbalanced force, which is going to be me, pulls her back into the game. Let's go. So everyone, that was our session on inertia. Hope you enjoyed. See you next time. Bye-bye.
Thank you.
Now we have Team B represented by Asmi Asudani of grade 10 and Amelia Binoy of grade 10. Let's welcome them.
Namaste, awesome students.
I'm Asmi.
And I'm Amelia. Asmi, थोड़ा side हो ना, मैं stage पे दिखाई भी नहीं दे रही. Wait a second. Have you gained mass?
I'm not sure about that, but I've definitely gained inertia.
Inertia? You guys must be wondering what inertia is.
तो चलो दोस्तों, आज हम चलेंगे inertia की magical दुनिया में. वो tendency जो इतनी आलसी है कि तुम्हारा सबसे ज़्यादा आलसी दोस्त भी intimidate हो जाए.
Inertia, in layman's terms, is the universe's way of saying, change? Nah, I'm good here. It's what makes your bed seem even cozier in the morning.
Inertia को imagine करो जैसे तुम सुबह बेड से उठे नहीं और मॉम बोले उठो. ये वो फीलिंग है जो कहती है बस 5 मिनट और सोने दो. ये था inertia of rest, when a body wants to stay at rest no matter what happens around it.
Asmi, Imagine you're in a train.
Okay.
ट्रेन चल रही है. Imagine कि suddenly ट्रेन ने ब्रेक मार दी. What will happen to you? अरे अस्मी, तुम आगे गिर जाओगे ना.
हाँ.
Think of inertia of rest as the I'll start exercising tomorrow mentality, and inertia of motion as the I'll stop eating chips tomorrow mindset. We've all been there.
Of course. Since I have such an amazing audience with me right now, I shall present one of my top secret experiments.
Let's see it.
तो इस मज़ेदार एक्सपेरिमेंट के लिए मेरे पास है ये स्टैंड और ये बकेट. बकेट को मैंने स्टैंड पे एक धागे से लटकाया है. तो आप सबको क्या लगता है क्या होगा अगर मैं ये धागा नीचे खींचती हूँ जोर से?
The whole thing will snap off, right?
अरे अमीलिया, थोड़ा सोच के बोलना चाहिए ना. चलो, लेट्स ट्राई इट आउट.
अरे, how did that happen? I expected the whole thing to fall off.
Well, जब मैंने इस धागे को खींचा, मैंने सिर्फ धागे पे फोर्स लगाया, और क्योंकि इस बकेट में इनर्शिया है, ये फोर्स ऊपर नहीं जाने देता. इसके कारण ये ऊपर वाला धागा नहीं टूटता. Now, what do you guys think will happen if we try to pull the thread a bit slower? Did you see that? The entire setup fell. This was because when we put force on the thread, the bucket also came in motion with it, since we were pulling the thread slowly, and so the thread on the top broke.
Acha, now it's time to show my smarty skills.
Okay.
Asmi, you see that apple over there?
Yeah, looks very delicious too.
Arey, no, don't eat it.
Oh.
Poke the apple with the ruler.
Okay. Like this?
Yeah.
Oh.
What do you think is going to happen when you shake the ruler?
Well, my smart brain says that the apple will fall. Isn't that obvious?
Well then, let's test your smart brain out.
What? I guess my brain's not that smart. Nonetheless, how does that even work? It seemed like gravity went out for a walk when I shook the ruler.
When you shake the ruler, you're only applying force on that one object, not on the apple. So the ruler moves downwards while the apple remains in the same position.
Oh, okay. Amelia, now my time to shine. एक शर्त लगाओगी?
हाँ हाँ बताओ.
अगर मैं ये पेपर इस बॉटल के नीचे से बॉटल को बिना गिराए निकाल लेती हूँ तो?
Impossible. ये तो बस magicians ही कर सकते हैं. अगर तुम ये कर पाए ना, तो मैं तुम्हें अपना लंच का पिज्जा दे दूंगी.
ये हुई ना बात.
I'll show you how it's done.
Come on. Ooh. Seems fun, doesn't it? Well, just like in the previous example, यहाँ पे हमने सिर्फ पेपर पे फोर्स लगाया, इसलिए सिर्फ पेपर मोशन में आया, जबकि बॉटल को रेस्ट पे रहना था, इसलिए वो रेस्ट पे ही रहा और बॉटल नहीं गिरा.
And just like in the first example, the bottle fell when she tried it pehle because she was pulling it slowly. She'll
If
show
I
you
try
again.
to pull it slower, the bottle will come in motion with the piece of paper, and so it will fall.
अच्छा, moving on. Any cricket fans here?
Here,
तो आप सब तो IPL तो देखते ही होंगे.
of course, IPL देखना ही पड़ता है अगर क्रिकेट फैन हो तो. लेकिन my favorite team lost the match.
अरे अस्मी, हारना जीतना तो चलता ही रहता है.
But I think it was all because of the boundaries the other team hit. How I wished the ball would just stop rolling on the ground.
But it can't because of inertia.
Huh?
According to Newton's first law of motion, also known as the law of inertia, the ball will continue moving on the ground unless it hits the boundary or gets slowed down by friction.
That was interesting to know, but I wish we could have a rematch.
I wish we could have a rematch of the bet that we made. But oh well, I guess we've got to move on.
क्योंकि सच्चाई ये है कि अपने कंफर्ट जोन में रहना वैसा ही है जैसे हर दिन पिज्जा का सेम फ्लेवर खाना. जबकि दुनिया में और भी तो फ्लेवर्स अवेलेबल हैं। चेंज को अपना लो, ये है तुम्हारे ऑसम एडवेंचर्स के लिए रॉकेट फ्यूल।
Like a rocket breaking free from Earth's gravity, we all have the potential to soar and reach new heights by overcoming the lazy pull of inertia.
बस बस, थोड़ा ज़्यादा हो गया। How about a quick physics joke?
Go ahead.
फिजिक्स वाले कभी राज नहीं कहते, क्यों?
Kyunki they don't have any?
नहीं, because once they start, they don't stop due to the law of inertia.
If you guys understood that joke, it means we've done our part.
And that was all about inertia, the super lazy tendency.
Wait. Before we end, a special message for all of you. Do not let the lazy pull of inertia keep you after lunch. Thank you.
Thank you.
We have Kothari International School presenting on the topic inertia. We are inviting Team A comprising of Mahi Tyagi of grade 12 and Rudra Vinayak Bhatt of grade 12. Let's welcome them on stage.
Why are you so late?
Arey, coming, just 1 second.
At least tie your shoelaces.
Arey, nothing happens. I'm 70 kgs. These wouldn't stop me any which ways.
I told you you'd trip.
Sorry, guys. Anyways, moving on. Mahi, what did you do in the morning?
Well, I got up, brushed my teeth, took a bath, got ready and got here.
Fair enough. Now, just consider yourself to be on a holiday or on a vacation rather. How would your routine pan out then?
Well, I'd probably sleep till 11 a.m.
Did you guys notice the small change in human behavior? Once we are in a specific environment, in a specific condition, we tend to perform the same activity again and again. If you are going to school, we'll be performing the same activity 5 days in a row. However, when there is a shift in environment, our body, our mindset, it tends to perform in a different way. Same thing applies in the physical world as well to the objects. This concept is known as inertia.
So you're telling me I can't change my habits until I put effort into it?
Well, yes, an external effort is pretty much important. Now, inertia is one of the foremost concepts in the world of physics. Now, physics, guys, is a very interesting subject. It's much more than a tough board's paper. Physics is a fabulous subject. It dwells deep into the understandings of the phenomena of each and everything occurring in and outside us. And one of the cornerstones in the world of physics has been the law of inertia, given by none other than the great Sir Isaac Newton.
One of the greatest minds in the history of science, Sir Isaac Newton, introduced the laws of motion in his book, first being the law of inertia. Now, to understand these laws of motion, he explained to us the law of inertia, in which a body tends to remain in a state of rest or motion unless external force acts upon it. Now, here we have 3 types of inertia. First being the inertia of rest, where a body tends to remain in a state of rest unless external force acts upon it. Now, a very common example of this is when we're sitting in a vehicle. For example, if we're sitting in a bus and all of a sudden it starts moving, that is inertia of rest. Your body will be pulled backwards. Now, Rudra will explain inertia of motion.
You guys remember my rather unplanned entry, right? Where I tripped accidentally due to my laces. That was an example of inertia of motion. Whilst my body was in a state of motion, while bringing it to abrupt change, although my lower body was still attached to the ground, so it got transferred into a state of rest immediately, but my upper body that was detached from the ground, or was rather indirectly connected, was unable to change its state so perfectly. Hence, resulting in an outward movement.
Well, it was inertia and his clumsiness. Now,
more of inertia.
Inertia of direction, that is, a body will continue to move in the same straight path unless external force acts upon it to change its direction.
Well, to be very honest, we need to be very grateful to Sir Isaac Newton. 50 to 60% of mechanics is covered by only these 3 laws. In chemistry, you've got an exception for almost every other reaction. In English, you've got language. In biology, you've got the terminology. In maths, you have, maths. But in physics, you've got 3 laws of motion that completely define the mechanics. Modern day mechanics as well. And unlike chemistry, Newton wasn't proven wrong over here.
You speak a lot, Rudra. Well, anyways, namaskar everyone. Today, I, Mahi Tyagi,
and me, Rudra Vinayak Bhatt,
are going to introduce the topic of inertia via our experiments.
And whatever she's saying about me, just ignore it the same way we ignore air resistance and friction in the case of free fall kinematics.
So firstly, let's understand inertia of direction.
Now, how often have we seen multiple satellites being launched into space? When satellites are launched, they are given a certain kind of, like a tremendous kind of force, which generates a certain orbital velocity in the satellites. This orbital velocity helps the satellite to reach to the elliptical orbit of the Earth. But once it reaches to the orbit of Earth, the engines are switched off.
But why do they continue to stay in motion?
Well, exactly. If you look at the diagram over here, we have shown certain forces acting on the satellite.
So the forces acting on the satellite are the centrifugal force acting away from the center of the Earth, the gravitational force towards the center of the Earth, and inertia acting tangential to the orbit.
So what happens over here is, as soon as the satellite enters into the orbit of Earth, it generates a certain kind of inertia due to the movement of the Earth. That inertia is slightly transmitted into the satellite as well, and it continues to perform rotatory motion as well. Therefore, neither collapsing nor escaping tangentially.
Enough with the boring words, let's get to the experiments.
Okay.
So first, we have the square base that we've connected to 4 strings, on which we're going to place a bowl of coins. Now, let's try swinging it in the air once.
Oh.
Why didn't it fall?
Well, it didn't fall because of inertia. It inherited a certain kind of inertia of rotation, therefore neither changing its direction, neither changing its state of position.
A very similar concept can be seen in roller coasters. Have you ever gone to one of those scary 360-degree roller coasters and you think you're about to fall, but you won't? That is because of inertia.
Wait, I want to try this experiment as well, but I'll try it without the coins. So,
Why did it fall this time?
well, as you can see in the diagram that we have shown, the gravitational force and the centrifugal force are balanced. Therefore, there is no additional external torque. Neither is there an external torque, nor is there any external force acting on the satellite. However, as soon as an unbalanced force acts on the same satellite, it will change its state of inertia. Now, inertia tries very hard for an object to remain in its state of rest or in state of motion or in the state of direction. You know, it kind of reminds me of one of those iconic poems written by Shri Atal Bihari Vajpayee ji, कि हार नहीं मानूंगा, रार नहीं ठानूंगा, मैं काल के कपाल पर लिखता हूँ, मिटाता हूँ, गीत नया गाता हूँ, गीत नया गाता हूँ.
How is that related to inertia?
Inertia is not giving up. It
Okay.
continues to function. Now, let's give us an example of inertia of rest and inertia of motion by an application of Galileo's laws that we have presented over here in the form of an inertia walker.
Now, we have an inertia walker here with us, but to understand that, we first need to understand Galileo's experiment of inclined planes. That is, when a ball or a body rolls down a slope, it rises up to another slope to the same height in the same direction. But why does this happen? Why doesn't the ball slow down? This, according to Galileo, has been proved that when an object rolls down an inclined plane, it climbs up another. Using this concept, we have created the inertia walker. That is, when we place this inertia walker on a slope plane, this has a metal spherical ball inside of it. Here is how the inertia walker is made. So basically, we take a rectangular piece of paper, then we cut it into this shape. The circular edges help to make the ball roll down the slope. Now, what happens is, because when the ball rolls down, and it rolls down the circular area, it tries to climb up the other slope that is being created. But due to the weight of the ball, it moves down. We're going to show it to you. Ruth, can you demonstrate, please?
Can we please have a volunteer from the chair, if possible?
If anyone would like to come up.
Anybody from the audiences as well? Anyone? Can we greet her with a huge round of applause, please?
Now, would you please place the inertia walker here?
Here?
Yeah. As you can see, it moves down. But due to this barrier, it gets stopped. That is inertia of motion. Because of this external force that is being applied due to this barrier, it gets stopped in the middle. Now, would you place it like this, please?
Okay.
As you would see, the inertia walker doesn't move this way because the curved surface is to this side. So, it doesn't create a slope. Now, would you want to race with me? We have two inertia walkers
Yeah,
here. Let's see which one works better. I guess I won that round. Thank you so much for coming up here.
Thank you very much.
Thank you. Now, moving on to more daily life examples.
Yeah. Now, there's a great example of the relation between inertia and mass that is given in our scriptures as well. Everybody remembers the great Mahabharata as well. Like, we all have read the great Mahabharata as well. So what happened was, just before the war of the Pandavas and the Kauravas, so Shri Krishna and Arjuna, both of them, they went to Hanumanji. Now, Hanumanji is a Chiranjeevi. He was existing in the Dwapar Yuga as well. So now they went to Hanumanji and said कि प्रभु हमें ना आपकी मदद की ज़रूरत है, आप आ जाएंगे तो हमारी सेना का बल बहुत ज़्यादा बढ़ जाएगा. तो हनुमान जी ने बोला ये तो मेरे लिए देखो असंभव है, क्योंकि मेरा जो काम का कार्यालय था वो मेरा त्रेता युग में था, अभी द्वापर युग में उतना है नहीं, पर मैं आपकी इनडायरेक्टली हेल्प कर दूंगा. What did he do was that he gave them a certain assurance that he will always be on the chariot that Shri Krishna and Arjuna were traveling. So it's also a trivial fact as well that once you actually see the photo of Shri Krishna and Arjuna on the chariot, you will also see a small idol of Hanumanji with like this. Why? Because he was guardianing the entire chariot. So now come to the war now. Two people, Maharathi युद्ध के, अर्जुन और करण आमने सामने. करण का जो रथ था वो नॉर्मल सा था, साधारण सा था. अर्जुन के रथ में हनुमान जी थे. So now, whenever both of them used to shoot their arrows at each other's chariots, what used to happen was, अर्जुन मारता था तो करण का जो रथ था वो काफ़ी पीछे चला जाता था, 20-25 मीटर पीछे चला जाता था. और करण मारता था तो अर्जुन का रथ बस 4-5 सेंटीमीटर पीछे जाता था. और श्री कृष्ण ये देखकर करण की बड़ी तारीफ करते थे कि क्या मारा है तीर, कितना ज़बरदस्त तीर मारा है. तो अर्जुन ने एक बार सुना, 2 बार सुना, 3 बार सुना. अर्जुन बिकेम क्यूरियस. He asked कि प्रभु मैं उसका रथ 20-25 मीटर पीछे डाल रहा हूँ और वो तो बस 4-5 सेंटीमीटर पीछे डाल रहे हैं, तो आप उसको वो क्यों कर रहे हैं? तो अर्जुन ने, तो श्री कृष्ण मंद मंद मुस्कुराए और उन्होंने बोला कि अरे नादान, उसने हनुमान को पीछे कर दिया है. Which shows that due to the immense mass and the immense weight that was concentrated on the chariot of Arjuna, it became immensely tough for it to displace itself and change its inertia of rest. That was beautifully explained in our scriptures as well. Now, moving on to some other examples of rotational inertia. In the modern age, we all are great climate activists as well, and we are shifting slowly and steadily towards renewable sources of energies. And how are they actually formed? Due to the movement of turbines.
So, as we can see, we have a turbine here. Unless we put external force on it, in real life, it is like a gush of water or a gush of wind. But here we have this system. So unless the external force acts upon it, the turbine will continue to stay in its state of rest.
Absolutely. And if you move it quickly, like if you move it rather quickly, then it will still continue to remain in motion. And if we would have been in a vacuum condition, which unfortunately isn't true, then it would have kept on rotating continuously because no external force would have acted on it. But over here, we have got friction and air resistance, which eventually stops the wheel. The same concept, if you notice, is also seen in fans. Once you switch on the fan, it takes the fan quite some time to actually swirl itself. And then once it gets enough energy to overcome the entire inertia of rest, it becomes an inertia of motion and reaches its optimum speed. Now, if you switch off the fan at this very moment, then the fan again takes a lot of time to decelerate and eventually come into rest, thereby ensuring that inertia of rest and motion both exist in the case of a fan as well.
Such a similar concept can be seen in bicycles and everything around you. Basically, inertia is an inherent property, and we've gotten so used to inertia that we don't even realize it happening around us. Like turning a doorknob, turning on a fan, it's something we do every day, but we've gotten so used to the fact that inertia is around us, we don't even consider it.
Okay, is this a sealed bottle, Mahi? Because I'm extremely thirsty. I just want to drink.
I'll open the bottle for you.
Wait, I'll open it. I can open it. Eventually.
Why did it take you so long to open that bottle?
Now, when the bottle was sealed, it was in inertia of rest. It takes a lot of force in order to remove an object from its inherent state, thereby requiring a much more amount of force to displace it from its inertia of rest into a state of slight motion. So whenever a bottle is sealed, you will often notice that it takes a lot of energy to first slightly bring it in motion. However, once it ever so slightly turns, it becomes much easier to continuously rotate it. and thereby you can open the bottle, open a door, etc.
But
Multiple things
what
can
if
happen.
inertia wasn't there?
Oh,
What would
That's-
happen? Is
that's-
it really that important?
that's a really serious question. Now, let's move back to some basic concepts that we studied in grade 9th and then in grade 11th as well. It was related to the atomic structure. Now, there have been a lot of wars regarding whose atomic structure was better. But there was this one great fellow, Sir Rutherford, who actually gave us a model that the arrangement of electrons around the nucleus is similar to the arrangement of planets in our solar system. But his theory, although it looked good in paper and on graph, it proved to be immensely wrong. Why? Because electrons are charged particles. And when these charged particles revolve, they certainly have some acceleration. And due to that acceleration, an electrostatic force is created. And that electrostatic force is now unbalanced by any other component, thereby getting the entire system failing and the electrons collapsing into the nucleus. And if I remember it clearly, it was Sir Maxwell who calculated this time period, and he said that it would take only 10 to the power minus 7 seconds for the entire nucleus to completely collapse. Well, that doesn't happen.
Why doesn't it happen though?
Exactly. Because of inertia, we've got an additional component of force that retains the property of any kind of matter susceptible to any type of change. So whenever any kind of change or any kind of force is acting on that matter, the matter wouldn't simply move because of inertia. So if inertia is not there, then the entire Earth, it would be reduced to a plump of matter.
Because the Earth would lack the electrical forces required, and Earth would simply collapse into a clump of matter.
Just like that.
Just like that.
Thank you very much.
Thank you.
Now we have Team B represented by Aditi Rana of grade 10 and Ranveer Singh Luthra of grade 12. Let's welcome them.
Where are you?
Wait, I'm coming.
Hey, are you okay? How are you about to fall?
Hi, I am okay. I'm sorry. And about that question, sorry. There's something called inertia.
Inertia, what? What is that?
It is a tendency of any body. It is the inherent property of every body in the world that it maintains its state of rest and motion without a force acting on it. If an external force any acts on it.
Okay.
Namaskar everyone, I am Ranveer Luthra from Kothari International School, and today we are here to talk about inertia. I am here with...
Namaskar, I am Aditi Rana.
To understand inertia, we have to start at its core. Here in front of us, we have a pendulum, to which we have attached a string with a weight on it. When we freely suspend the pendulum, it will move something like this. And when we try to stop it... So Aditi, now that you've seen the experiment, can you tell us what you have learned?
Let me try. The swinging motion of the pendulum showcases inertia, as when the pendulum is rest, it remains at rest until acted by an external force, continuing its swing due to its mass, I guess?
Yes, you're right. Do you know that there are 3 types of inertia? Inertia of motion, inertia of rest, and inertia of direction.
Wait, can we go step by step?
Yes, no problem. Inertia of motion. Inertia of motion is a property of a body to maintain its velocity resisting changes unless an external force acts on it. In front of us, we have a wheel. I, of course, couldn't get a bicycle in here because it's obvious. So we have a wheel that will be portrayed here. When I apply a force on the wheel's rotational momentum and mass will help it to spin, and only stopping will friction and air resistance stop it.
I don't agree with you. It will stop moving when I will stop applying force on it.
No, see, whenever you stop apply force, the body will move due to its inertia. You can try it for yourself.
Oh my god, I was wrong. Inertia of motion do exist.
Yes, and a fun fact, if we try this exact same experiment in a vacuum, the wheel will continue to spin on forever as there's no air resistance.
That's interesting.
Now, I would like to invite someone from the audience to basically play a game of tug of war with me. Anybody?
Let's give her a round of applause, guys.
Hello, thank you for joining us. So I would like you to pull on the rope here. Please don't release it until I say anything. So here, as you can see, we both are pulling at the rope and the system is currently at rest because there's an equal and opposite force. We learned about that in Newton's third law, which we will not talk about right now. If she accidentally releases the rope, I will fall back. We'll tell you that later. Can you please release the rope? See, now.
In a tug of war with two people, if one suddenly releases,
Thank you.
the remaining one tends to stumble due to inertia of rest, resisting the change in motion.
Moving on, now we have inertia of direction. Inertia of direction refers to the tendency of an object to maintain in its direction of motion unless an external force acts on it.
I think I have an example for this. Go Ranveer, ball.
Here you go.
When the ball hits the bat, the ball may not follow immediately on the bat swing due to inertia of direction.
See, if you didn't still get it, I'll tell you another example, a real life example. I know every day you sit in a car, if you're going around in a car in a sharp turn, your body tends to lean towards the outside of the curve due to its body's inertia as it resists its change in state of motion. This happens due to your body wanting to move in a straight line when the car turns.
Inertia is vital. It explains various phenomena from vehicle safety to planetary motion, fundamental to understanding physics.
Inertia surrounds us constantly, influencing objects' behavior, yet goes unnoticed due to its seamless integration into our everyday life, making motion and stability seem natural.
Well, that's all for today.
Thank you.
With this, we complete the presentations on the topic inertia.
And now it's time for the judge's opinion.
The runner-up is Kothari International School, Noida. The participants are Mahi Tyagi and Rudra Vinayak Bhatt.
And the winner is Shiv Nadar School, and the participants are Arika Sahai and Sanvi Gupta. Congratulations to the winners.